Back to the Pierce-Sears male-female problem. All right. So if you have a two-way table, what does a conditional probability look like? Okay. So if we know that a randomly selected student has pierced ears, what's probability the student is male? We did this in chapter 2. Raise your hand if you know the answer to that question. If we know they have pierced ears, what's the probability they are male? Yes. So what you know, you isolate that row or column. So we know they have pierced ears. So out of just the people with pierced ears, what's the probability the student is male? 19 out of 103. All right, 19 over 103. Now this part is new, how to set this up, okay? The probability statement has this bar in the middle that means given, okay? The thing you put second is what you know happened, all right? So I know the student has pierced ears. I put that second. What I'm trying to find the probability of, I put first. What's probability the student is male, given they have pierced ears, is how you read that, okay? All right. What if we know that a randomly selected student is male? What's the probability that the student has pierced ears? Raise your hand if you can tell me the answer fraction to that. Catalina? Yes. So you guys, this time I know the student's male. So I isolate the male column. What's probability they have pierced ears? 19 out of 90. And this time, how I would write my conditional probability, okay, what I know goes second. I know the student is male. What's probability they have pierced ears? Okay. So this is the definition of conditional probability. The probability that one event happens given that another event is already known to have happened. So this is how we write a conditional probability statement. So whatever is second is what we know happened. Okay, we already know this. The first thing is what we're trying to find the probability of. Okay. And then I would also write what this lovely bar means. When you read it, it means given. So what's probability of A given B already happened? Okay. There's a formula for conditional probability. I actually only recommend you use it when you don't have a two-way table. So if you have a two-way table, just do it the way we just did it. Isolate the row or column and calculate your probability by the table, okay? So anytime you have a table, don't use this formula. But there are times you won't have a table, all right? And so you'll need this formula. So the probability of A given B is equal to the probability of A and B divided by the probability of B. Write this formula down. So on the top, this A and B is the probability of both at the same time, okay? A and B at the same time, the overlap, right? Divided by the probability of what we know happened. Order matters, okay? Order matters because if I switch this, the probability of B given A, now my formula is the probability of B and A, which actually is the same. You're still just talking about the overlap, right? But now I would be dividing by the probability of A. So whatever is second goes in your denominator, okay? So order matters. This formula is given to you on the AP exam. I forgot yesterday, but I'm going to pass out one of those laminated sheets for you guys so you know where those are. You can use that laminated sheet on every test. All right, there's only 2 formulas for this chapter, though, on that sheet. okay? And this is one of them. The other one's the general addition rule, okay? All right. So back to our Facebook, Instagram problem, right? People who use Facebook, people who use Instagram, people who use both. This would be one where I do not have a table, and so I need to use the formula to calculate my conditional probability. So it says, what's the probability that a randomly selected resident who uses Facebook also uses Instagram? So when you set up your probability conditional statement, all right, you have to know which one goes first and which one goes second. The one that goes second is what we know happened. What do we know happened? We know they use Facebook, so I'm going to put that second. Okay, so what's the probability they also use Instagram? Here's my formula. Instagram and Facebook divided by the probability of Facebook. All right. In the top is the overlap, right? The probability of Instagram and Facebook is what percent? Yeah, it's the overlap, so it is 25%. All right, divided by the probability of Facebook. Now, this would be everybody who uses Facebook. What is that? 68%. And yes, you should divide those on your calculator and get an answer, okay? Now, if it goes the other way, our answer changes. Okay, what's the probability that a randomly selected resident who uses Instagram also uses Facebook? What do we know happened? Instagram goes second. We know it happened. What's the probability they use Facebook? So in the top would be Facebook and Instagram. And in the bottom now goes the second thing, Instagram. The top is the same, okay? I and F, or F and I, it's still the overlap, so it's still 25% for the overlap, but this time I'm dividing by the probability of Instagram, which is what? 28%. So it's actually going to be a lot higher chance here if they use Instagram that they use Facebook rather than the other way around, right? There's going to be a way higher chance if you find an Instagram user, they're probably a Facebook user as well, but not the other way around. Obviously, show your work, okay? So if you use the formula, show the formula. I would not use the formula on the tables, so you don't need to show it, but otherwise show the formula, okay? Another thing, you are allowed to write out words. This is actually supposed to be the given bar right there, right? So if you had the probability of uses Facebook, given uses Instagram, you can write out whole words there as well if you don't want to define your events. Otherwise, technically, I should define my events I and F at the top, right? Uses Instagram, uses Facebook. Okay? Okay, let's try the Titanic problem. So we've got our survived and died people and our first class, second class, third class people. Okay, so let's start with part A. Find the probability of T given S. And they tell us that T represents a third class passenger. What's probability someone's a third class passenger given that they survived? Now, don't use the formula because we're back to a table, okay? Raise your hand if you know the answer to this. AJ?
It's 151 out of the 42.
Yep. Good job. All right, so we're saying of the people who survived, what percent were third class? Okay, easy peasy. Now it says, given that the chosen person is not a first class passenger, all right, what's the probability that he or she survived? All right, so part B, we got to write out our statement first, okay? Given the chosen person is not a first class passenger, what do we know happened? They're not first class, okay? We know they're not first class. It says right here, F is first class, so I'm going to do F complement. We know they're not first class, right? What's the probability he or she survived? So S goes here. All right, this one you have to think a little bit more, okay? If they are not first class, what are they? Second or third? What are we going to have to do on this one? Yeah, we have to add a little bit together here. So what's the probability they survived? So 94 plus 151 divided by the total of those second and third class people. And get your percent. All right? So you may have to do a little addition sometimes too with what you're isolating. Don't be afraid of that. Okay, here's another one. Let's just say they give us some random probabilities. Probability of event A is 50%. Probability of event B is 23%. Probability of A and B happening at the same time is 15%. All right? What's probability of B given A? So first we would have to do the formula. There's no table. All right? So we would write it out. Order matters. Okay? Whatever goes second goes in the bottom. So what goes on the top? Yeah, this means the same thing as this. So 0.15. What goes in the bottom? Yeah, 0.5, and then you would calculate that. All right. Now, if you're going the other way around, I would do the probability of A and B divided by now the probability of B, the second thing. What goes in the top? 0.15 again. What goes in the bottom? And you'd calculate it. Okay? All right, you guys, that's it. We're going to do independence at a later time. So grab your 5.3a worksheet. Let's try this. Okay, so the first two, you guys just use the formula. All right, be sure you're dividing by the thing that is second. So you get 0.75 for the first one and 0.214 for the second one, or whatever you rounded to, okay? All right, and our lovely table that you can barely see here. What's probability that a randomly selected student got an A or a B? Now, a lot of you guys wrote the formula out, which is great, A or B. So the probability of getting an A is 20 out of 100. The probability of getting a B is 15 out of 100. Do we need to subtract anything? No. Why do we not have to subtract anything? They are mutually exclusive. You get an A or a B, there's no overlap. You cannot get both, right? So the time that they won't be mutually exclusive is if you were to say like A and female, okay? So if you're going to do one row and one column, you will not have mutually exclusive events, all right? But if you pick two columns, they're mutually exclusive, or two rows, they're mutually exclusive, okay? So anyways, you get 35 out of 100. What is the probability that an A student is male? We know they're an A student. That goes second. What's probability they are male? 12 out of 20. Don't use the formula. It's just more confusing, I promise. I used to teach that, and it just confused people on tables. Just don't use the formula, all right? What is the probability that if a student was female, they got a passing grade? We know they're female. That goes second. What's probability they passed? So 8, 9, 13, and 8, all out of 44. 38 out of 44. Okay. What is the probability of a male student given that they failed? So you guys, probability of male given failed. Failed goes second. When they say given, that's what you know. All right. So probability of male given failed, meaning I need to look at my F students here. What's probability they are male? This over this. 7 out of 13. What's probability a random selected student is male? So just 56 out of 100, right? What's probability somebody's male? What's the probability of a female student given they got a B? So that means given they got a B goes second. What's probability they are female? So you're going to isolate your B students here. What's probability they are female? 9 out of 56. I mean 15. Yeah. What is the probability that a randomly selected student passed? All right. So out of everybody, an A, a B, a C, or a D out of 100 is 87 out of 100 students passed. Okay. Any questions on this worksheet? All right. Go ahead and put your name on it, pass it over, and you can start the homework.